Imagine you're holding a simple object in your hand, a coin, a pen, anything at all. You let it go, and without hesitation, without asking permission, it falls. You've seen this happen so many times that your mind doesn't even question it anymore. Of course it falls. That's gravity, right? A force pulling things down. Simple, obvious, settled. But what if I told you that this obvious explanation, the one almost everyone carries around with quiet confidence, is not actually the truth? What if the very thing you think you understand better than anything else in physics is hiding a reality so strange, so counterintuitive, that it reshapes the way you see the universe itself? Because here's the uncomfortable part. The deeper you look at gravity, the less it behaves like a force, and the more it begins to look like something far more bizarre, something that bends space, something that slows time. Something that doesn't pull objects the way you think, but instead quietly rewrites the paths they follow. And the strangest part of all, this isn't some distant, abstract idea happening in black holes or faraway galaxies. It's happening to you right now. Every step you take, every second that passes, every ray of light that reaches your eyes is being shaped by this hidden structure you've never been taught to notice. So the question is not whether gravity is real. You already know that. The real question is, have you been understanding it completely wrong your entire life? Stay with me, because by the end of this, the ground beneath your feet won't feel quite as simple as it did before. When people first hear the word gravity, they almost automatically imagine an invisible force pulling things downward, like some cosmic hand reaching out and dragging objects toward the earth. It feels intuitive because that is exactly how it appears in everyday life. You drop a ball, it falls. You jump, you come back down. Everything seems to confirm that gravity is simply a force of attraction between masses. But this picture, as comfortable as it is only a rough approximation of something far more subtle and deeply fascinating. The truth is that gravity is not really a force in the traditional sense at all. It is a manifestation of geometry, a reshaping of the very stage on which the universe exists, space and time themselves. To understand this, imagine that space is not empty and rigid, but flexible and dynamic, like a fabric that can bend and stretch. When a massive object like a planet or a star exists, it does not just sit there passively. It changes the structure of space and time around it. It creates a curvature, a kind of indentation in this fabric. Now, when another object moves nearby, it is not being pulled in the way a magnet pulls a piece of iron. Instead, it is simply following the natural path within this curved geometry. The object is doing what everything in the universe does, moving in the straightest possible path available to it. The catch is that in a curved space, what looks straight is not straight in the way we normally imagine. This leads to one of the most misunderstood ideas. Objects are not being pulled toward Earth in the way we instinctively think. When the moon orbits the Earth, it is not constantly being dragged inward by a force that it is somehow resisting. Instead, it is moving freely along a path that has been shaped by the Earth's presence. If you could somehow remove all other influences and place an object in this curved spacetime, it would simply follow the curve naturally, without any sense of being forced. It is a bit like rolling a ball along a curved surface. The ball is not being pulled sideways by some mysterious force. It is just following the shape of the surface beneath it. Now here is where things become even more surprising. The sensation you feel when you stand on the ground, what you call your weight, is not actually the feeling of gravity pulling you down. That idea feels so obvious that it is almost impossible to question. But if you think carefully, the sensation of weight comes from the ground pushing up against your feet. If the ground were suddenly removed, you would not feel a strong pull downward. Instead, you would feel weightless as you fall. Astronauts in orbit are constantly falling toward the Earth, yet they feel no weight at all. That is because there is nothing pushing back against them. So the feeling of weight is not caused by gravity itself, but by the resistance to the natural motion that gravity defines. Gravity is guiding you along a path through space-time, and the ground is preventing you from following that path. The ground is, in a sense, interfering with your natural motion, and that interference is what you experience as weight. This flips the usual understanding on its head. Instead of gravity being the thing you feel, it is actually the thing you do not feel when you are allowed to move freely. Another layer of misunderstanding comes from the assumption that time is constant and unaffected by gravity. We tend to think of time as something that flows uniformly everywhere, ticking away at the same rate regardless of where you are. But gravity does not just bend space, it also affects time. In regions of strong gravity, time actually passes more slowly compared to regions of weaker gravity. This is not a theoretical curiosity or a mathematical trick. It is a real, measurable effect that has been confirmed by precise experiments. Imagine two identical clocks, one placed on the surface of the Earth and another placed far out in space, away from significant gravitational influence. The clock on Earth will tick more slowly than the one in space. The difference is incredibly small, but it is real. And when you consider extreme environments like near a black hole, the effect becomes dramatic. Time can slow down to such an extent that, from the perspective of a distant observer, it nearly stops altogether. This means that gravity is not just shaping where things go, it is shaping when things happen. Then there is the question of light, something we usually think of as untouchable by gravity because it has no mass. If gravity were simply a force that acts on mass, light should pass by massive objects unaffected. But that is not what happens. Light follows the curvature of space-time just like anything else. When light passes near a massive object, its path bends. This has been observed in the way distant stars appear slightly shifted when their light passes near the sun. In the presence of extremely strong gravity, such as around a black hole, light can be bent so much that it cannot escape at all. This leads to the idea of a black hole, an object so dense that it curves space-time to an extreme degree. Inside a certain boundary, every possible path leads inward. There is no route that leads outward, not even for light. It is not that the black hole is pulling light back with some irresistible force. It is that the geometry of space-time has been warped so completely that all directions point inward. Escape is not prevented by strength, but by structure. At this point, it might seem like the older idea of gravity as a force is completely wrong, but that is not quite fair. The earlier understanding, developed through careful observation and reasoning, works extremely well for most everyday situations. It allows us to predict the motion of planets, calculate the trajectories of projectiles, and design structures that stand firmly on the ground. It is a remarkably effective approximation. The problem is that it is not the deepest description of reality. It is like describing the surface of the ocean without acknowledging the currents beneath. It works, but only up to a point. When conditions become extreme, when speeds approach the speed of light, or when gravitational fields become very strong, the simpler picture begins to break down. Predictions start to deviate from what is actually observed, and a more complete understanding becomes necessary. This deeper understanding does not discard the older one, it expands upon it. It shows that what we thought of as a force is actually a manifestation of something more fundamental. There is something deeply humbling about this shift in perspective. It reveals that our intuitive understanding, shaped by everyday experiences, can be profoundly misleading when applied to the underlying nature of reality. The world behaves in ways that are not always aligned with common sense, and uncovering those behaviors requires a willingness to question even the most basic assumptions. Consider how strange it is that something as familiar as falling could be reinterpreted in such a radically different way. Instead of being pulled downward, you are moving along a path determined by the curvature of space-time. Instead of feeling gravity, you feel the resistance to it. Instead of time flowing uniformly, it bends and stretches in response to mass and energy. Instead of light traveling in straight lines, it follows curves that reveal the hidden structure of the universe. All of these ideas challenge the way we naturally think, but they also open the door to a richer and more accurate understanding of reality. They show that the universe is not governed by simple, isolated forces acting in empty space, but by a complex interplay between matter, energy, space, and time. Everything is connected in a way that is both elegant and subtle, and perhaps the most striking realization is that these effects are not confined to distant galaxies or exotic objects. They are happening all around us, all the time. The curvature of space-time caused by the Earth is what keeps you grounded. The slight difference in the flow of time between different altitudes is constantly present. The bending of light by gravity is quietly shaping the way we observe the cosmos. These are not abstract concepts. They are part of the fabric of everyday existence. What makes this so compelling is not just the scientific accuracy, but the shift in perspective it demands. It asks you to let go of a simple, comfortable picture and replace it with something more complex, but also more beautiful. It invites you to see the universe not as a collection of objects interacting through forces, but as a dynamic, interconnected system where geometry itself plays the central role. In the end, the misunderstanding of gravity is not just about getting a scientific detail wrong. It is about how we interpret the world around us. It is about the difference between seeing something as it appears and understanding it as it truly is. And once you begin to see gravity in this deeper way, it becomes clear that what seemed obvious at first was only a shadow of a much more profound reality. So after everything we've explored, the falling objects, the curved paths, the strange behavior of time, and even light itself bending under gravity, what seemed like the most familiar idea turns out to be one of the most deceptive. Gravity is not a simple pull, not an invisible rope dragging things downward, but a quiet reshaping of reality itself. It is the architecture of space and time guiding everything along paths we cannot see, yet constantly follow. And perhaps the most powerful realization is this: the universe does not owe us simplicity. It does not organize itself in ways that are easy to imagine. Instead, it reveals its truth only when we are willing to question what feels obvious. The moment you stop accepting "it just falls" as an answer, you step into a deeper way of thinking, a way that doesn't just observe the world, but tries to understand the hidden rules behind it. That is where real curiosity begins, not in having the right answers, but in refusing to be satisfied with easy ones. Because every great discovery, every shift in understanding, starts with someone daring to say, "What if this isn't the whole story?" So as you walk away from this, I don't want you to just remember facts about gravity. I want you to carry a different habit of mind, question the ordinary, look twice at the obvious. Because the universe is far more surprising than it first appears, and the truth is often hiding in places we think we already understand. Good luck on your journey of curiosity and discovery. Keep asking, keep wondering, and never stop exploring. Thank you for your time.